Hello, everybody. Good morning, good evening, good afternoon, and welcome to Going Meta episode 19. Hi, Jesus. How is it going?
Hi, Alex. It's going great. Different background for a change. London office today.
Yes.
And,
Cool.
I've been told I'm in the noisiest room, but I hope it's not. It's just that there's some trains passing by, which makes it, quite nice. But if the noise is too bad, just let me know. But I think it's okay.
It's okay. I think it's not too bad, at least at the moment. But we'll hear when the train goes by, I guess. But should be fine.
Is there now?
Is there now? Okay. No, nothing. Okay.
Good.
Well then,
Excellent.
I think it's good. You ready for summer vacation, or did you already go? Or
Yeah, no. Just little, short, like half week type of break, but I still hope to take a longer one towards the end of August. So just before episode 20, I suppose,
20.
right?
Yeah,
To
yeah.
So,
Yes.
so yeah. What about you? Have you been away already, or?
Not really. A little bit, but I was already in June, so I'll take off a week in August in 2 weeks' time.
Excellent.
So yeah.
Good. Yeah, I guess it's this time of the year where you really want to take a little break.
Absolutely. Yeah. The weather is usually good. Not so nice this week here in Munich, but that's how it is. Hi, Felipe, watching from Portugal. I guess you've got better weather than what we both have. I don't know how it's in London at the moment, but here it's raining.
And it's nice, but not very summery. So it
Yeah.
won't go over like 20 degrees. So it makes us want to go south. And
Yeah.
Probably not as bad as it's been over the last couple of weeks. I've
Yeah.
heard, in Spain, Italy, and some places. But yeah. Good.
Exactly. So
we have notes
this
coming
one,
up.
yeah, exactly. Before we dive in, mentioning nodes. So this will be our developer focused or data science focused practitioners, users, whatever you want to call it, featured event of the year. It's nodes. It's happening on the 26th of October. We will be publishing the agenda soon. So our colleague Michael is relentlessly working on building the agenda, accepting sessions, and building it all together so that it works across time zones. Because the goal again this year will be to make it as time zone agnostic as possible, so that not even that, no matter where you're based, you can watch it live during your daytime. You don't have to get up early or stay up crazy late. There will be content right for you with people from the region. So we'll try to make it happen again. And that's currently in the process. But you can already register. Registration is open. Go to the link I put in chat, or just go to neo4j.com/nodes 2023. And there you can put it in your calendar by registering already now. Or during the next upcoming days. What you can also do is register to one of the upcoming Road to Nodes workshops, which will be hosting from 20th of September. I put the link is a little bit a long one. I should probably make but it's just fresh off the press. I'll make a bit.ly link that's a little bit more consumable than this behemoth of a three-liner link. But you get to register for, or you can register for 4 of workshops. One is more of an intro session, and also covering Neo4j. We will be going into geospatial data towards the end. We will do some data science stuff with graph data science. And we are covering a broad range of topics. So if this is interesting, something more hands-on, 2-hour sessions, then register for them as well. And if you register for one of those, you automatically also will be added to the nodes pool. So easy. We will be repeating this throughout the coming weeks. So, don't forget.
Of course.
Yeah. But today, ontology versioning in Neo4j. So this was, you told me this was a YouTube comment, I think a couple of weeks ago, or months even maybe. Somebody
Yeah.
and we had it.
Maybe a bit longer, but it was, because the videos are up there. Sometimes you get comments later on, and I believe one of the episodes we did import an ontology from. I remember, I think it was web project like we're going to be using today, and someone asked, could we talk a bit more about how do we manage those ontologies, how do we version them and things like that. So yeah, I thought it would be a good idea. That's always a useful. I mean, it's a recurrent question, right? Versioning graphs is always a thing, and in the case of ontologies, it's no exception, right? So I'll explain, give a bit of context as always in the introduction, but that's the idea for today. Yeah,
that's good. Yeah, that's good. So again, feedback is always open. Ideally live now during the stream. So if you have any questions, any comments, anything else you'd like to get to us, then this is the best way to let us know. Put it in all of the chats. We can see them, and I will read them out to Jesus as we go along. But obviously, yes, the YouTube video, the YouTube playlist is another option where you can find all the previous 18 episodes on demand and watch them there. And if you put a comment there, we'll see it as well. But it is obviously a little bit more indirect than if you just use the live feature now.
Good stuff. Are we ready? Should I start sharing my screen?
I think we can. Yeah, we can go ahead again. Like I said, anytime anybody wants to say something, just type away.
Perfect. So let me share my screen. Let me know when you can see it. I'll try to share the right one. Should be this one. And as always, I'll start with a couple of slides.
Yeah, here it is.
That's what you have on the screen, and we'll take it from there. Good. Let me go on full screen for this part. It's going to be just 3 or 4 slides, but just to give some context. So yeah, as you mentioned, Alex, we're going to be talking about ontology versioning in Neo4j. And I always like to take the why angle, why we do things. We give you tools, we give you solutions and recipes to do certain tasks, but this is part of a bigger picture. And why do we want to use ontologies in the first place is something that I wanted to get back to, and also add references to some of the sessions that we've had over the last few months, right? So ontologies is a way of formalizing knowledge about your domain. It can be seen sometimes as a schema, as a model of the data that lives in your graph. And the powerful thing about ontologies is that they are expressed in a formal language, and that means that we can do things with them programmatically. We can automate tasks, and that's where it becomes really interesting. So over the months, like I said, we've done things around inferencing, reasoning, right? Doing, in episode 2, we talked about semantic search. We used an ontology to add structure, to add knowledge to a collection of, I think in episode 2, it was a collection of articles. And we show how having an ontology made it possible for us to do things like implementing semantic search, semantic similarity, which is something that we repeated again in episode 16. Also using taxonomies and using specific similarity metrics. But again, having an ontology will enable this type of reasoning-based use cases. We talked also specifically about reasoning and when populating knowledge graphs in episode 4. So all these, is of course pointers again for you if you're interested to go back to those. But one area is this idea of doing some smart data processing based on the information captured in the ontology. That's the inferencing part. Then there's another part which is more focused in the interoperability, right? An ontology is a description of the elements of the categories in a domain, and if we agree on this vocabulary, if you want, then we will simplify things like data exchange, interoperability, things like knowledge graph construction. If we have a well-defined target model and expressed by an ontology, we can build data ingestion pipelines. And we talked about that in episode 6, how having an ontology, we could build in that case, I think we generated the cipher statements to ingest the data from CSV files to populate a graph according to that ontology. So again, the ontology captures knowledge about the domain, the data that you hold or want to hold, and then you can use it in a number of ways. And well, these are the kind of two categories with the what else? Oh yeah, we had a similar idea. So instead of using it to build the knowledge graph and to build the data ingestion pipelines, in episode 5, we look at having a data set, overlaying an ontology made it possible for a consumer application to, through the lens of the ontology, be able to explore the data set and make it kind of data set agnostic. So any other application could explore the data through the same ontology. And we used Streamlit in that case. But of course, it could have been any other data consumer. So, many different applications and more detail on those specifically in these chapters. Worth mentioning, of course, that it's not exactly an ontology, but it's a formal definition of constraints, something like what shackle does. And we've talked about in a number of episodes, 3, 9, and 11. We talked about shackle specifically to define constraint shapes in your graph. And we talked about graph expectations as well, right? Which was this kind of Python wrapper to make it.
Yeah, that was an interesting episode. Yeah.
Exactly. So, and again, because this is formalized in the form of a it's not an ontology, but it's not very different in terms of artifacts. So this versioning that we're going to be talking about today would also apply to any constraint definition expressed in shackle. So more references there. So I hope that gives a bit of context on why we want ontologies in the first place. And then the second point is, of course,
and sorry to interrupt here quickly, but a link to all the previous episodes is every time you find it in the video description on YouTube, and I put it just in chat. There's a Neo4j landing page with collection of all the videos, so you can just click through there,
or you go adding the link to the GitHub repo. Well, because I don't know if that's cross-reference as well. So there's that repository.
It might be, but I put the
maybe that one contains it all. Yeah.
The GitHub repo is also in each episode, but let me put it in chat as well. That's a good point.
Yeah, because from there you have both the recording and the pointer to the resources. Because of course we'll make all the code and all the assets that we use today. We'll make them available for you to replay the session at home. So. Yeah, so I was saying that that's how we use ontologies, but then the reality is that ontologies change over time, naturally, right?
Yep.
A description of your model. I mean, as you probably build new data into your knowledge graph, you have to expand this description. And when things change, there are very common questions like, precisely what has changed. And that's the whole point of versioning, right? And when we have multiple versions of an ontology, we want to say, what's the delta between these two? Right? What has changed? I mean, it's one of the common ones. The other one is I want to get the most recent, the current version of an ontology. Right? Or in the same vein, be able to travel back in time and say, I want not the current version, but the version of that particular point in time, or version X or version Y. So these type of ideas around traveling back in time or being able to compare when things change is exactly what we want to cover with ontologies, or the versioning exercise that we're doing today. I mean, it's important to understand that I'm focusing more on the not so much on the development tracking of changes, which is probably more something that you would do in something like GitHub, right? So we're working on an ontology, we're collaborating, you and I. We push changes, we evolve it until it gets to a point where it's kind of production ready or ready to be released. And that's the kind of thing that we're going to be tracking today. So the not so much the individual changes in development, which, like I say, probably is something that would be done in some traditional change management or
change log kind of way, and version control, exactly, where that's something you would want to know, okay, what has changed, what's the detail,
exactly, because there you want to you want to know not only what has changed, but who has changed it, when was it changed, things that were reverted. I mean, it's a level of granularity and detail which might be an interesting exercise, but today we're focusing more on kind of these kind of less granular, but more like there's a new version of this particular ontology. and that's what we want to try.
Let's skip the building part, and we look more at the commitment has been done, new version is applied or is published, and then what's going on now? Do we use the old version? Do we migrate to the new version?
Correct.
Yeah.
Or when you, because that's the thing, when an ontology changes, there's some impact in consumer applications. So when you want to upgrade to the new version of an ontology, it's useful to get a well-defined delta. That's what's been added. That's what's been removed. That's exactly what's changed, and also be able to analyze the downstream impact of those changes. So that's the approach that we're going to follow today. Again, we tend to use Web4j because it's an open source free ontology editor, ontology development tool, but you can replace that with whatever tool of choice or approach that you follow to develop your ontology. So there will be a development tool, a development environment where you create your ontology. It will be typically a visual one like this one, but it can be, some of the teams that we work with like to develop their ontology, in text editors, which is also absolutely fine. But whatever you have there should work. Then there will be some kind of versioning logic. We will decide how we want to version, and I'm going to talk about that in a minute in the next slide, because there's different options. And ultimately, we will persist the different versions and the deltas in Neo4j. So in a way that the final product in Neo4j can be queried by users, consumers of any kind, with questions like the ones we've discussed a minute ago, right? So there's a user, there's a consumer that wants to know what has changed, and they might be able to go to a dashboard and find the delta between one and the other, or they might query an API. But once the information is in Neo, you can query it and in different ways. So that's the idea that we're going to be implementing today. Now, like I mentioned before, you have different approaches, and I'll try to cover the two main ones today. The first one would be, and this would be if I double click on the database here, on the product, on the version stored in the version ontology stored in the graph database. So we have probably the cleanest approach, which is each version will live in an independent database, an independent graph. Right? So there's many different ways of implementing that, but today what I'm going to do is use the multi-database capability in Neo4j, where you can create a database which is completely isolated and independent from the others, and write to that database one of the versions. Now, because what we want to do is precisely query across versions to compute the delta, we need some mechanism to be able to do that. And in Neo4j, what we have is this idea of a composite database, like Neo4j Fabric, which is now called Composite, which is effectively a virtual database that kind of wraps a number of actual physical databases, if you want, and makes it possible to query across them using Cypher. So that's one possibility. I say that it's one, but it's not the only. You could have it in completely independent. Of course, this can live in a single database, in a single cluster, but you could have it in independent databases. Then you probably would not be able to use Composite, or it depends. You might want to do the composition in on the client side. So there's different variants, but that's probably the simplest one that we might think of, and that's the one we're going to be covering today. And you can have as many as you like, and like I say, the level of granularity here is probably from a released version, a production version, to the next, rather than every granular change that you might want to apply in development mode. So that's different databases for each version. And then the other one is, we have a single view, but we annotate everything. So we tag every bit with the version that it corresponds to. And because things can be added, things can be removed, probably you will have something. And again, I'm not prescribing what this can look like, because there's many different approaches to this, and it all depends how you're going to consume it. I believe there's some sessions on our YouTube channel where we've touched on the topic of versioning, and there's even libraries that help you with that. Because, I don't know, for example, in this case, you might just want to annotate every element with the version it was created, or the version when it was deprecated, or something like that, right? Because things can be also removed. It's probably less common in ontologies, but they could. Why not, right? So you would have rather than deleting elements, you could have logical deletion. Sometimes you want to also delete. I mean, that's where here I will not be very. I mean, I'll take a simple example and show it, but again, you can extend it or make it tune it to exactly the logic that you want to implement in your case. So I hope that
it always depends, right? I mean, what's how, like you said, how granular do you want to look into this? How much is this relevant to you? How much do you want to really know? and how much does this matter to you? If it doesn't, then obviously easy. But we assume obviously it does matter somewhat, and then you can always decide how much you want to go with this, and how much you want to have the user also work with it in the end. That's always another thing to keep in mind.
Exactly. Well, so let's go back to these. I mean, to these ideas. So that's the setup. So I've already opened here my web project, and I have my ontology there. I'm going to use one that I created a while ago with clothing materials. These are simple taxonomy of different clothing materials in a hierarchical classification, as you can see. And I mean, I will not go over the details of creating it, but it's pretty straightforward. I think in the Streamlit episode we go a little bit more into the how to construct this ontology. But in this case, let's say we have this initial version of the ontology, and we want to start implementing the versioning, right? So basically, whenever we get to a state where we have a released new version of the ontology, we want to push it to the Neo4j graph. If we go with the first option, where we have independent individual graphs for each one of them, what I want to do basically is extract that and send it over to Neo4j in a new graph. So I'm going to use in this diagram, I show that there's some versioning logic in Python. So I'm going to show that in a notebook just in a minute. But effectively, what the notebook is going to do is two things. Is first getting to web project. There's not an API, at least not that I'm aware of. So I've had to hack a little bit the extraction of the ontology. But basically, what you'll see, is that if you go to the list of ontologies, you can click here and you can say download. So when you download, you specify the serialization that you want, the LDFXML, turtle. So I select turtle and you say OK. That will be downloaded locally, and I believe that's somewhere here. So you will see. I mean, it's a bit. I mean, the thing is, it's downloaded as a zip file, so you can extract it, and there you have your clothing materials ontology. So
we only see the browser window though.
Oh, how's that? Is it? Did I not share the? Let me stop screen sharing and try again. So my intention was to share the whole window or the entire screen.
Desktop, yes. If you share your entire desktop,
hopefully that's back.
Yep.
Well, I mean, nothing special, but basically, it's downloaded locally and it comes in a zip file. If you unzip it, you get the clothing materials in a TTL file. So I don't want to do that manually every time. So I've, like I was saying, I've written a couple of lines of Python. It didn't take a lot more than that, as we're going to see. But that's what we are going to be doing. So to extract that ontology, let me know if is this readable. Shall I make it a bit bigger, maybe?
This is readable. Do you mind clicking on the hide button on the little pop-up?
Sure.
That's
So I always forget that.
That's all right.
Good. So well, just in the header, we're going to do the usual installing of Neo4j and rdflib, which is what we're going to be using. Good. That shouldn't take long. That's good. Now let me remove the output because it always makes it clearer. So we just do the imports that we're going to be needing, and I mean this fragment here basically provides this function. I mean a couple of them. The first one that we're going to use, but it's a very simple function that all it does is take the ontology and send it to Neo4j. And all it does is call the Semantics import statement, import procedure. So let's just assume that this store ontology will take the driver that we use, and it's already connected. I've pre-populated these with the URL of the sandbox instance that I've already created here. So it's an empty sandbox. So you can see, usual process, sandbox.neo4j.com. You create an instance. I always go with the blank sandbox, and you have all the details here, right? The connection string, the user, the password. All you need is there. And in order to save time, I've created it before, but there you go. It's an empty one. So this is my connection string and the password that's required there. So what are we going to do? And here's where I was starting. So I'm getting the current version of the ontology from the development tool, which in this case is Ontology, and store it in Neo4j. So the first thing I have is the URL of the download URL for Ontology. And as you can see, it takes two things. It takes the project ID, which I'm going to show in a minute what it is, and it takes because it's an authenticated session, it will take the session ID that you can get from the cookies. So that's the kind of hacking that I've done. It's pretty straightforward. So let me show you what it does. So if I click on this, it will ask for the project ID, and all you have to do is go to Web Protege, and the project ID is this fragment here. Oops, sorry. You can get it in different ways, but the easiest is to get this string here.
From the URL. Yeah.
So after project, so if we go there, we can paste the project ID. And the second part is the session ID from the cookies, and that's a bit more hacky, but it's just getting the cookies. So if you do, just inspect here, you can go to application, and you will get there your cookie, your session ID. So copy it. Oops, did I copy it right? I hope I did. So, and we can then close this and be back here. So with this, we should be ready now to connect to this URL and passing the cookies, because that's exactly what this does. As you can see, we're just using the standard requests to send an HTTP request, a GET request to this URL, which is the one that we created with the project ID. And we're passing as parameter the cookies with the session, so that it takes the authentication. And that downloads, like we saw before, a zip file that we need to unzip. That's what we're doing here. And once we unzip, we get the file that it contains. And what it's going to do is just extract the text in it, the ontology basically, and send it to Neo4j using the store ontology, right? Which is the function that I described here. All it's going to do is take the ontology and call this Neo4j NTNS RDF import and persist it on the graph. Now, as you all know, before we can write to Neo4j as RDF, we need to configure a little bit the graph and actually create a database. Because if you remember, we said we're going to create one database per version. So what I'm going to do is come to my Neo4j browser and say, okay, let's call, this is going to be my database version 0, right? So why not? I can call it Onto v0. Right, so that's a create database statement. It's going to create a new database, and I can say once it's ready, I want to use Onto v0. So if I say that, it will move to my database. And as usual, like I was saying before importing any RDF with Semantics, you might be familiar with this fragment here. All I'm doing is I'm going to create a uniqueness constraint for URIs, and I'm setting up the graph with a configuration. Let's run it, and I'll explain what's happening here. So the first one, like I say, just creates the uniqueness constraint on URIs, so that any statement that contains the same URI will be merged together, which is the basics of RDF, right? Now the second part is saying, well, I want to import the data as a property graph, of course, but I want certain properties to be multi-valued. And because this ontology is multilingual, because has all the elements in multiple languages, I want to keep them all. But these are stored in the label and the comment property. So these are the only two that I want to have multi-valued. And I also want to keep the language tag, which is a feature of RDF. That's basically, let me show you an example, right? So if we have, for example, leather, you see that leather is described in English, in Spanish, and in French. So it has multiple values for the label, and these values come annotated with the language string. And the same happens with all the rest of the elements, right? So that's the way it is. So and by setting the configuration in that way, I'm saying I want to preserve those. I don't want any data loss, and I want to keep the language tag. So that's the configuration that I've set. And now I'm in a position to come here and say, okay, now read from this web protege, connect this environment, get this project, which is the clothing material ontology, and push it to Neo4j with this configuration. So if I run that, and there's no problem, hopefully.
And you didn't have to specify.
Oh. I did something wrong. Look at that. So
yeah, okay.
Sorry,
I was wondering. I was wondering if you don't have to specify that you want to send this to the v0.
Exactly. Because look at this. The second parameter is the database, and I was trying to send it to the default one, which is Neo4j, and it didn't work because in Neo4j we have not created the setup, the constraint and the configuration. So it's telling me, hey, I cannot do that because you need this and that. And so you're totally right. We should be sending these to the database that we created, and that is actually we called it Onto v0. So if we do that, let me go back here, and we set the proper Onto v0. So if we rerun that, hopefully now we will re-extract it and send 133 triples to this graph, where we now should be able to see them, right? So there you go. So we have our ontology here, and won't spend much time on the exploration here, but you see the taxonomy, right, with the clothing materials. It's showing multiple values in French, in Spanish, and as you can see, as an array, as we said, and well, the whole taxonomy, but now seen as a graph. There you go. So we have the first version of it. Now the whole point is we're going to change these. We're going to make these evolve, right? So let's say, okay, we have wool here. I don't know. Let's put something random. I'm going to create a subcategory of merino, right? It's going to be I don't know, fine merino. There you go. So we create a new one, and we have another one which is going to be ultra fine merino. 2 classes, for example, and let's create a relationship. Let's say, okay, I'm also going to be creating a relationship, which is an object property in RDF terms, in ontology terms, and we're going to call it something like similar to. I mean, we don't want to make a lot of sense. It's just want to make the ontology change, right? Let's say similar to is the relationship, and we're going to define the relationship between 2 clothing materials. So one clothing material is similar to another clothing material. So I can state that between any pair of materials. There you go. That's one example of change, right? So that we don't need to do much more than that. It's been saved, and now we can come here. Actually, before we do that, because we're going to do exactly the same, we're going to create a new ontology. Sorry, new ontology, a new database in Neo4j. And to do that, I'm going to basically replicate exactly what we did before. So we're going to create Onto v1. As soon as it's ready, we're going to use Onto v1. It might take a few seconds. It's still not ready, but here we go. It's creating it. So hopefully it won't take more than a few seconds there. There you go, we have it. And if I retry using Ontology v1, we have it. And now we're going to do the same, exactly the same setup. So we're going to create a constraint, and we're going to set the same configuration, exactly the same. And yeah, so we are ready to go back to our notebook here.
Yeah.
And all I have to do is, this hasn't changed, so all I have to say is go now to v1. So it's still going to pull the latest version, which now has changed from web project, and it's going to push it to, hopefully the number of triples should be different, right? 133 should be a different
more.
So if I run it again, there you go, 144.
44.
That's good. And if we have our v1 here, hopefully soon we should be able to see that. There you go. We have an extended ontology, and there you go. We have our ultra fine and fine merinos here. We also have these similar to relationships. So we have a couple of additional elements as expected, right? So nothing surprising. And then maybe for a final change, I don't know, we can, I don't know, delete one of these. For example, we're going to delete the.
You could add another language. I can help. Give you
oh
German.
Yeah, of course, that would be another idea, and well, just try to make it a quick and simple one. And let's delete this one, and instead of similar to, we're going to create another one that's going to be called, I don't know, compatible with. And similarly, we're going to define that between general case clothing material and another clothing material. Again, not being very creative here, but the idea is just to implement.
Yeah, it's just for
exactly. And as we did before, we are going to create yet another database that we're going to call v2, for example. And as soon as it's ready, we're going to initialize it exactly in the same way. So we're going to say use Ontol v2. Still not ready, creating it. And once we have the three versions, what we're going to do is start querying across. So let's try again, use Ontol v2 and the same initialization, constraint and config. So we have it ready. And we can go for the third version. We're going to call Ontol v2, which again, as always, is going to take the latest version from Web Protege and push it to Ontol v2. Now it's 141. We've added some, we've removed some, so that's good. So now we have the three versions. We're kind of implementing these approach here. We have a number of versions, 3 in this case, living in the same database. Now we need a composite database that will let us query across all of them. And in order to do that, again, I'm going to copy here the fragment just to make it faster. But it's a pretty straightforward set of statements. I mean, you can do it from any database, from the system or from any other. But what I'm doing is I create a composite database, and that's instead of calling it create database, I say create composite. I call it Ontos. And I have to add references, or we call it aliases, to the different databases that we want to virtualize in this composite one. So we have the 1, the 2, sorry, the 0, the 1, and now the 2. And we give them these aliases until v0, v1, and v2. So if I create that, that should not take very long, and will provide us with this umbrella database that we can use to query across all of them. So I can go to Ontos, which is our virtual composite database, and here I can start running queries. And okay, let's go and start exploring the kind of questions that we were looking at before, right? So what has changed between version A and version B? Good. So what the query is going to look like is something like this. So as we've seen, in order to use a specific database, we specify it by saying, okay, use, for example, ontos. Let's say I want to query v0, right? And from this one, find, for example, the classes, right? And the classes would be, let's call it C1. It would be OWL __ class. Because, let me show that to make it clear. When we explore things here, we see that things, because that's how they're defined in the ontology, are declared as classes, right? Classes, and also relationships as object properties. But I'm looking for classes, right? That exist in the C1. Sorry, I call it C1 in the V0. Let's call it actually class 0 to make it more readable. So, someone needs access to the room. Just hang on a second.
That's what you get in the office, guys.
Yeah, no, they were just next door, and I thought they wanted to come in, but it's just next door. So that's we had Penny last time.
Yeah,
right?
exactly.
So
it's like almost a running gag now.
Good. Okay, so we I was saying that I want to get the classes from the version 0, and maybe we want to return C0.uri, so I can get, if I run this, and I've made no mistake, I get all the URIs, the unique identifier of all the classes in the version 0. Now, what I want to do is that both in 0 and, for example, in 1, and then see what's the difference between them, right? So in order to do that in 2 parts, I use the call syntax, right? So I say, okay, do this in, let's see if I have a good cipher composite syntax. Here, what we'll have to do is pass let's give it an alias to this. We can call this, for example, let's call it V0 class URIs. So I'm going to pass this to the second part, and I'm going to replicate exactly the same thing because it's identical. What I want to do is put that in this mode. Maybe it's going to be easier to read. And I want to do the same, for example, in 1. I'm going to get the classes in 1, and I'm going to call this V1 class URIs. Okay. Actually, instead of returning these, what I'm going to do is I'm going to return a collection. It's going to be more efficient. So if I do a collect of the URIs, and you do a collect, that should return 2 lists. Right? So
don't you need to change the variable here from Z0 to Z1?
I hope not, because, maybe it would be clearer, but it shouldn't be, because I suppose, given that they're inside its curly brackets, the scope is limited, but it doesn't hurt to make it, it would make it more readable, you're right. So if I return this list and V1 class URI list, that will give me 2 lists, the V0 and V1. Okay? And what I want to do is effectively compute the differences, right? So check the things that exist in V1 but not in V2, and we can do that, for example, with a list comprehension. We can say, give me the X in this list where X not in this one, right?
Okay. Yeah.
So basically that's saying iterate over the elements in the classes in the first, in V1, which is the second one, where they are not found in the 0 one. In other words, what has been added to the ontology. So that should give me an error, of course, because I cannot why does it not like it? Not expected. So I should be doing something, because this, can I not unwind?
Maybe you need another with and then return this as a variable.
I would expect, so if I unwind this as X not in, this would be a new class. that be better? No. So, oh, not in. That's, yeah, I should have read the message. That's so we're not. It's the order is wrong.
I
So
see.
X, not
Okay.
X
Yeah, I see.
in.
Yeah.
So no, X not in, but not X in. So that should give me, there you go. So we've detected the delta. So effectively, the two new classes that were added is the ultrafine and the fine merino. And we could do the same, in the, instead of looking at classes, if we look at object properties, object property, I think would be, I should call things differently, but I'm lazy and I'm just using the it's telling me that the similar to is the one that was added between one and the other. And I could do exactly the same between, here I'm doing it between 0 and 1. So if I do the class analysis between 0 and 2, it will tell me that there's only one, because the second version, if you remember, deleted one. Okay.
Yeah.
So we have now a complete representation of the ontology in each of the graphs. And we can, we have the logic that we can express in Cypher to answer this question about the deltas. Now, we would like that to look a bit nicer, right? Rather than having to write Cypher every time. What I've done is a very quick example of putting that in a dashboard. And dashboard, we have Neo4j to use. And it's already pointing at the database that we've created. And I'm going to say that I want to create a new dashboard. Yes. Pointing at the, let me find the right, oops, that's not what I want to do. So we want to get the details of the connection. So that's going to be the IP address. So that's where we want it to go. And the password is Neo4j, and this one here. And the database that we want to use, did we call it Ontos? We did, didn't we?
We did, yes.
Okay, perfect. So that's good. We stay with this one because we wanted to query the virtual one, the composite one.
Yeah.
Good. And I can start writing my queries. But in order to save time, I've worked on that a bit before, and I've saved a dashboard that should be hopefully stored in my local drive. It's on downloads. And it should be this one, div Neo4j. Let's load it. And what you have here, there you go. So it's kind of a nicer, it's not super beautiful. I haven't spent too much time, but as you can see, you have to specify here, I want to compare V0 with V1.
Yeah.
So the added classes are these two. There's no deleted classes, and the added relationship is this one. If I wanted to compare V1 with V1, of course, there should be no delta at all because it's the same. But if we compare V1 with V2, there should be some interesting results because there were no added classes, but we deleted one of the fine merinos and we replaced one relationship with the other. Again, the idea is not to build something beautiful. We could spend a bit more time, but you can have a dashboard that gives you this type of analysis, and we could do it deeper, not just classes relationship, but properties as well. And what you have is a way of basically do this analysis and keep every single version of the ontology available, which was the other question. I want to use version 2, version 3, but all you have to do is point at the right graph and you would get it. So very quickly, because I see that I'm consuming a good amount of time in this first part. The second part, so we said that maybe in some cases, we just want to keep a single version of the graph and we want to keep updating it. And again, the update can take different shapes. We said before that depending on how you want to use it, you might want to annotate, you might want to do logical deletions, actual deletions. So let's look at how we would go about that. So in order to do that, we might want to combine it with some external analysis, and that's what I wanted to explore here. So what I'm going to do is, okay, now we have, let's actually start again and take the, initial version of the ontology. Well, as it is, the current version of the ontology, and I'm going to put it on Neo4j, the database, right? So all I have to do is exactly the same. Just say, okay, I'm going to put it in Neo4j. So if I do that, it will go pick the current version from. No, didn't like it. Of course, we have to initialize it.
Yeah, exactly.
So let's go to Neo4j. And the initialization, as always, is the create constraint and then the config. Perfect. So let's run it again, and hopefully this time it'll go through. There you go, 141 triples. So we have the ontology in the Neo4j database. And now what we want to do is different from the previous case, right? So what we want to do is, okay, I have a new version of it. Let's do something like what we did before. Let's now remove the ultrafine and create the superfine. Okay. Perfect. And just a simple change, but again, the idea is to have something different. So what we want to do now is, okay, I have an ontology saved in my Neo4j database. I want to compute the delta offline, and then based on the differences, well, decide how to persist them in my graph, and that requires a bidirectional exchange of information. So the first thing is, okay, give me the current version of the ontology, and that we can get it from the RDF endpoint in Neo4j. So that's what we do in this section here. So as you can see, and you might remember from previous episodes, Neo Semantics offers an RDF endpoint where you can serialize the content of a database as RDF. So that's exactly what we're going to do. So we have this RDF endpoint as an HTTP endpoint here. So that's the URL of the database, name of the database, which is Neo4j, and we can send some Cypher query. And a query that would get me the whole content of the ontology would be get any resource and get any connection, any relationship, right? So that would get me everything. I could briefly show this actually directly from here. So if I take this query, I can show how this would work. So this is a post request that would be on RDF, Neo4j, Cypher. So all I'm doing here is using you can simulate HTTP requests from the browser. And that's the query. And I'm going to say that that would be it. I mean, the serialization by default is turtle. So if I say doesn't like it because it has to be quoted here as well. With that should work. No, doesn't like it again. Cypher. Have to be consistent on this. There you go. So now we can stream out the content of the ontology as RDF, and it should be identical to the one that comes from Web Protege, because that's the whole point. We're going to compare the two using an external library and then decide what to do with the delta. So these exists, and all we're doing from our code, from our notebook, is call that from Python, right? So that's the HTTP endpoint. That's the query that we're going to run. And we're specifying the format is turtle. Don't need to, because by default it's turtle, but anyway, it doesn't hurt to put it there. And again, it's an authenticated request. So post using the requests functions in Python, and we're passing hang on, what are we passing here? The payload, yeah, of course, the Cypher query and the format. So when we send that request, that returns the RDF stream that we saw, and we're going to load it into an RDF_lib graph object. So RDF_lib, as you might remember from previous episodes, is a Python library for using with RDF. And what we're doing is we're taking the RDF and building an object here. We can print it just to see what it looks like, and it will be exactly what we saw on the other side. So there you go. That's what we've just received, and it's exactly the ontology that hopefully we should. I'm going to clear the output just for clarity here, but we have it stored in the current version, current as in the current one stored in Neo4j, and we're going to do the same with the one coming from Web Protege. So we do exactly the same thing as we did before, except that instead of sending it now to Neo4j, we're going to build yet another RDF-lib graph here. So that's what we're doing. So if I do that, it should pick the current version. Perfect. Now it's stored there. And we can compare them. And compare them uses this very simple syntax. So these graph objects can be subtracted, can be added. And if we do new take away current, the new is the one coming from Web Protege, and the current is the one coming from Neo. So if we do a subtraction, new take away current, that will give me the newly added triples. And if we do the other way around, it will tell me the removed ones. So all I'm doing here is printing them. So if I do that, it's telling me, hey, you've added the superfine merino, correct? And you have actually deleted the ultrafine merino, which is correct. That's what we did. So now, as you can see, we're using the RDF lib to compute the delta for us, and we're doing it offline because we want to decide what to do with that. So we want to say, okay, maybe I want to add the triples, or maybe I want to annotate them with a timestamp, or maybe, like I said before, we want to delete the triples, so we want to just apply logical deletion. So we have full control here. The point is that we could call, and I will not go too much into the detail because I'm conscious of time here, but we can call a specific function that we call store onto delta. Instead of just literally pushing the ontology as we did before, we're being a bit more granular, and we're passing the deleted and the added, and we can decide what to do with them. In my current implementation, it's very simple, and it's doing as you would expect, the deletion and the addition, so nothing special. So the deleted are deleted and the added are added. But you could take control here and do any of the implement any of the logics that I was describing before. So let me run it. But what we should see, and just to see the difference, is something like this. So if I show what's in the ontology at the moment, so this is the graph that we have. And if we run the update, which basically, adds the new elements, and as you can see, it's added 3 and removed 3, the delta that we saw. Now we should see, if I rerun that, it might be a bit tricky to see, but if you see that's wool, and it has the where is it? Wool, that should have, there you go. So it has the superfine. I don't know if it's readable, but you can see it on the right-hand side, which is the newly added one. And in the previous version, we used to have the ultrafine, right? So we see that the change has been implemented. So we're keeping a single graph and we're updating it. But it's totally free for you to implement the logic that you want, and that's what I wanted to show. But I'll take a pause here. I hope that, because I realize that we've kind of consumed all the time. But as always, the notebook will be checked into GitHub as always, and you are free to play with it. So let me stop sharing and see if we have any questions.
Cool. Thank you, Jesus. I had one comment rather than a question before we dive into questions, and maybe everybody now can take some time to post their questions in chat if there are any. Is the last one you showed is particularly interesting because then you, like you said, is offline versioning. So you directly see, okay, I would imagine you work with your internal data, but then you pipe in some external ontologies and on top of what you're working with in your data architecture almost. And then you see, okay, there's a change has been published, version 50 of ontology on whatever is now live, and you say, okay, do I want to add this in, or is because this everything never change a running system is there for a reason? And you see, okay, this is great to see. Okay, what has changed? What has been removed? What has been added? And then you can decide without touching your live system.
Exactly.
Do I want to
That's
put
the
that
thing. In the first approach, you're right. We're creating a new database, and there's a new version of the ontology, and then it's up to the consumers to say, "Hey, I'll stop pointing to the previous one, and I'm going to start using the new one."
Yeah.
But it's kind of an additive change, and it's less disruptive. But if you have a single database, and like what we show in the second version, every change that you implement there, that you apply there, is going to affect directly to anyone's consuming that. So that's where you have to be careful and understand what you're doing, and basically define your versioning logic and implement it in that way. So yes, that's, and also to show different ways of tackling the problem there. So
absolutely. Yeah, and it's great to see, right, to directly go into the details and see, okay, what has changed, so you can compare and analyze.
And I suppose the thing is, it takes a bit more time and expertise on Neo4j, but I suppose you can build a pretty cool dashboard, with the changes, with some more visuals. Like a couple of weeks ago, I was talking to one of our colleagues who was looking at additional metrics about ontologies, right? So not just, in this case, we're focusing on the delta, but there's loads of, like, the level of the instantiation, any kind of metrics. So you can create a pretty rich dashboard, and that might be another chapter in itself, another episode of going meta in itself. So how we can create metrics in a dashboard for ontologies, for data sets. Yeah.
Cool. Let's quickly do some questions. Blagoya asks, what will happen in case you have RDF data in the graph in parallel with the ontology?
That very good question, and that's exactly the point where you want to use the second approach, because that will be normally. I would say normally that's what we have been doing in most of the episodes, right? When we have the ontology stored in the graph, together with instance data, in order to implement things like semantic search, semantic similarity, recommendations. He's totally right. The same graph contains both the ontology and the data. So you have to be pretty, fine-grained and granular about what you do. It's not like the first approach is pretty simple because it's isolated and all the changes, you know that it's not affecting the rest. But in this kind of situation, what will happen is that you will have to be more careful, and you have to take the second approach and understand, hey, when you have a new version, what happens to the instance data? How they're going to be affected? Because maybe some of the changes in your versioning logic is, well, maybe the instances that used to point to the old version now, point to the new version. It can become a pretty big problem, and that's something that I've been discussing with a customer of us, Walter Kluwer. They have a team that's pretty advanced in that, and they're dealing with that particular problem. So they have ontologies that change over time, and the problem is not so much in the change in the ontology, but what happens with the instance data that aligns with a changing ontology over time. So again, I'm not giving a single answer or a simple answer because it's a complex problem, but I would say that in that case, you have to be very granular and understand what's your versioning policy and take an approach similar to the second one. So understand what the impact of the change is going to be on your complete knowledge graph. That includes the ontology and the instance data, and determine what's the way you want to persist it in the graph. So something like the first approach probably wouldn't work unless you have design your data in a way where the instance lives in a database and the ontology lives in a separate one, which would give you probably more flexibility.
Yeah. And then there's another question from Eshwar. I guess he wants to know about Protege. Again, if there's any reason why we picked that, and if we can.
Just simplicity. Simplicity is availability. The fact that it's a free one, you just create an account, and for basic, things like what we've done today, it's pretty cool, and it works very nicely. But again, the good thing about ontologies, when the tool implements W3C standards like OWL, RDFS, it doesn't matter which tool you use. Ultimately, you will have a way of extracting it, persisting it as RDF, and the process will be exactly the same. You will not have to point to this URL, web project download URL. You will use whatever your preferred tool uses, but it would not be a bigger change than that. Right? So that wouldn't. And I think I mentioned it in the slides. So we're using web project, but again, replace that with whichever ontology development tool of choice you have.
Yeah. Okay, cool.
Yeah.
Nice. Blogger adds the same applies for the shackle constraints as well, and I guess that's
exactly. Well, that's yeah, absolutely. I mean, this is it does totally. I mean, from the versioning point of view, it absolutely does. The way we manage them in Neo4j is slightly different because we don't persist a graph-based version of. I mean, you could, because ultimately shackle is RDF, so you could store it. But the way we work, because shackle are typically used to validate the shapes of your data, to keep the shape of your graph under control. So what we do is we persist the shapes, the shackle shapes, in a kind of compiled form in Neo4j. So it becomes kind of a little bit of a black box in the sense that you have a compiled version that runs on your graph. But I see that, to your point, Blagoja, I think it is exactly the same. So if you want to have a graph representation of your shackle shapes, exactly the same logic and the same approach would apply as we have used for OWL, and the same for SCOS, and the same for any RDF data in general.
Cool. I see no more questions, so I think that turns us around to the end of the episode. Thank you very much for watching. Thank you for your questions and feedback. Thank you, Jesus, obviously for presenting and for the demo part. I think that was very insightful, especially the two different approaches, how to work with versioning, how to play with it. Again, as we said in a little summary now, it depends a lot what you want to do, what your goals are. If you go with the composite view, or if you directly commit, but then obviously look at the the differences between the two versions, and have a try, have a go at it. The content will be available on GitHub
exactly
soon.
Yeah.
So you can play with the Python notebook and with the with the predefined Cypher queries, I guess.
Yeah, exactly. I'll put all the queries that we run, the creation of the composite database, the notebook, of course, and so all will be there for you to play and to try at home. So yeah, and any questions? I mean, this was someone's request, but we're listening. So any ideas we're taking. So.
Absolutely.
Reach out.
Give us a maybe before we leave, somebody on this stream now has written a book recently.
Oh, right, that's true.
And I'll just drop it in chat as a closing link for you to explore. So Jesus just published together with Jim Weber, another colleague, a knowledge graph, building knowledge graphs, a practitioner's guide book. And you can download that for free on our website. Link is in the chat. Link will also be in the video description. So that's something maybe we look at next time.
Yeah, that would be a good idea. Maybe have a chat about the content and maybe take some questions. But yeah, that really happy with that, with the release of the book. So I'm really excited to have it out there and looking forward to hear people's feedback and hope it's totally aimed at practitioners, pretty much like what we do in this series. So yeah. I love that practical angle and yeah, I think that would be great to spend some time talking about it.
Yeah, we should do that. So in terms of streams, Thursday this week, so in 2 days, I'll talk to Dave Eitel about lessons learned from real-world graph application development. So he will share some tips and tricks about data modeling, graph data modeling, obviously, cipher optimization, memory allocation, how to work around the tripping points, I guess, when you start developing with Neo4j and start developing with Graph, common mistakes you can make that could take you a long time to come around again. So that should be insightful and interesting. So that's happening on Thursday, same time as today. So check it out. Follow the YouTube channel, subscribe to YouTube channel so to get notifications about when we go live next. And I hope to see you then. And yeah, wish you a good rest of the week, everybody. Thank you very much.
Bye, everyone. Thank you.
Thank you. Bye-bye.